Two cones are shown. The heights and bases of cone 1 and cone 2 are congruent. So if we look at cone 1 and cone 2, the problem is telling us that their heights are congruent. So the height of cone 1, which I'm going to draw in here with a red segment, the height of cone 1 is the same as the height of cone 2. So congruent means the same. We also know that the bases are congruent. So the base of the cone is the circle here. So if the bases are congruent, that means that this yellow circle in cone 1 and the yellow circle in cone 2 are the same size. So they have all of the same dimensions. In cone 1, the vertex. So the vertex, there's a lot of vocabulary in this question. Vertex is here. Is directly above the center of the circle. In cone 2, the vertex is directly above a point on the circle. Select the phrases that correctly complete the sentences, comparing the cross sections and volumes of cone 1 and cone 2. So this says the area of a cross section parallel to the base at the same height in each cone is. So if we are cutting a cross section parallel to the base, that means it's going in the same direction as the base. So if we were to take this cone and we were to slice it at the same height in cone 1 and cone 2, and then open it up and look at the 2D figure on the inside, we know that it would be a circle, because if we're making a cross section parallel to the base, the cross section is the same shape as the base. We would also know that the area of those two cross sections would be the same. So here the first blank here is equal for cone 1 and cone 2. Because the bases of cone 1 and cone 2 are congruent, and the heights of cone 1 and cone 2 are congruent, if we cut a cross section parallel to the base at the same height in each cone, the area of those cross sections will be the same. This means that the volume of cone 1 is equal to the volume of cone 2. If we look at our volume formula from our reference sheet, volume is equal to 1/3 pi times the radius squared times height. If the base of cone 1 and cone 2 are congruent, then we know the radius is the same in cone 1 as it is in cone 2. We also know that the height of cone 1 is the same as the height of cone 2. So both variables that we have to substitute into our volume equation are congruent for cone 1 and cone 2, which means if we were to fill out the volume equation, if we were to complete the volume equation for each cone, we would get the same answer both times.